So today, unfortunately, very sad day for me. It's our last day together in class per se, but we're still going to be touching base whenever you need any assistance, reach out as soon as
Mhm.
possible. Don't get stuck for too long, because that's what you have to do on the job and in life is collaborate and communicate. Many people
Mhm.
reach out to me in the middle of the night or anytime like by this I've been working on this stuff, I'm stuck. If I'm turning around, I grab my phone, I see it, I'm like, okay, try this, try that, and I go back to sleep. And then the next
Mhm.
morning, hopefully everything is fine. So it's good to try solutions yourself, but at some point, communication, collaboration is key for team success and individual success as well. So
Yeah.
today we'll talk about libraries and frameworks. We talked a little bit about those libraries yesterday, but there isn't much else to a library than, I mean, we've been looking at a lot of stuff lately, right? So let me go back to our folder. We did exercise 3, for instance, employee.
Mhm.
Let me look at this. So we created an employee class or an employee file per se, which is got the class. This class, when it gets saved, it becomes like a module. We can have multiple classes. This is just employee. Maybe we have another class for department, and the
Mhm.
department is going to have all the information. So we can use that class to create multiple departments, sales department, this department, their locations, their VP, their so and so and so. We can use
Mhm.
another class for our products or the services that we provide and so on. So when you package all of those modules together, it becomes a library. And then the library is something that we need to import to do separate functions. So let me go back to, where was I? I think I have to go into our classroom. Yeah, if we go into our classroom, I haven't published it yet, but I just made a few notes of the things that we needed to discuss today on the libraries. And let me maximize this. So again, definition of a library, right? We've talked about libraries multiple times, the uses of libraries. You can write something once and never have to write that piece of code again, but you can reuse it as many times as possible. So some libraries that we're going to be using been written by others in the past. We don't need to know what's in there. We just go in, we grab that library, create our objects from that library, and we are able to pull the attributes from the object, or we are able to call the methods within that object to be able to do something in particular. So Python itself comes with a standard library. Oops, what am I doing? Oh, okay. I think that's okay there. Yeah. Python comes with Python comes with a standard library which we've been using quite often, right? So a few of the things that we might talk about in terms of a Python standard library, maybe, oops, I don't need to open a new one. Let's take a look at, close this, we don't need that, we already talked about that. Let me go back to, yeah, that's week 5, that's fine. Let me open a new one actually. Let's open a new folder and call it libraries. Okay, within this, I'm going to open a new Python notebook or Jupyter notebook. So we can go ahead and import or just use Python's libraries, the regular ones that we've been using, like the print function, all those different functions. Those are all part of the Python library. If we need to use an import code or say a math library, we need to go ahead and import the math library. When we import the math library, we then have access to all those functions that are being used for the mathematical operations, right? So we can also import a library and use an alias, let's say M, and then we can use M instead of math. I think it would be better for me to use Visual Studio because we're going to be seeing all those different pieces that can be enabled. So let me go back to Visual Studio and create a new folder here. Oops, not there. In here and call it day 10. Within day 10, I want to create a new file and say libraries. In here, I would like to import, sorry, I need to add the extension, libraries.py. Excellent. So I will need to import math. Since we've imported the math library, now I can call it. And with that period, that dot notation, I have access to all these different functions. I can get a cosine, I can get the seal, it's like the rounding up, and the floor is rounding down. You can also have a lot of different math operations that are available for us. We don't need to reinvent the wheel. We can use a square root operator or function, for instance, and it tells you it returns the square root of x, where x is going to be what you enter in here. Okay, so for instance, if I put 5 in there, and let's say I'm going to say, let's say, let me call it number. I stand up so I got it better. I can actually work hard and smart when I'm standing. So let's say a number should be whatever somebody inputs. Enter a number. Hopefully the guy is going to input, oops, and enter a number. And let's make sure that we convert that to an integer. Now we want to get the square root of that number. We can go ahead and call it square root. If I can spell, that would be good. We can go ahead and utilize that, printing the number, say square root of number is square root. And with that, we can write a simple program that imports this math library, and we can use that by having math.square root. And if we execute this, it's asking us to, oopsie, I need to clear this. Let me stop that first. Let's enter 25, gives us that. Let's clear it because my screen looks horrible. So probably spell that right this time around. So if we execute that, asking us to enter a number. If we enter 16, place 16, tells us the square root of 16 is 4. Now we could have used it as import m, that as m, and instead of writing math, now we have to use m, and that should be easier, right? If we want this, it's still going to give us the same value. Let me move this to the next line. So if we find the square root of 100, oops, wrong place again, tells us the square root of 100 is 10. We could be even more specific and say from math import square root. So it tells you all the different modules that are present within this library. So the library has multiple modules. So in here, it's telling you math module, square root, and the access. Square root is a function within that module. So module, library, they are all interchangeable. A library is a bunch of modules, okay? So now I can go ahead and just type in square root. I should be just fine. But if I wanted to use, maybe give an English word that I want to use, I can say import that as square root. Probably not a good idea to use that word. Let's say square root. Now I can call it square root, and it should be just fine. So there are many different ways that you can import a library. You can import just the entire library to have access to all the functions. But if you don't want to have too much, depending on how large the library is, you might want to import just a particular function and use that. But now if we want to use, say, the floor function, we will not be able to use it because we have to write another import statement. So that's why sometimes it's better to just import the entire module and use every function within that module as you need it. Does that make sense? Everybody good with this? Excellent. So similar to how we created our employee class, and in here we're saying, not there, in here we said, oops, not there either. Save that, yeah. Which one is it? Oh, this is programs. I want to look at the employee one. Where was it? Oops, never mind. It was in here. That's the one we did in our example 3. So in example 3, we're able to import employee. Within that employee, you can see that the employee had multiple functions. If we decided to import just one thing, then it would import only the display employee. So we could have gone ahead and said from employee import, and it will import just display employee. And remember, if I wrote that correctly, there's an underscore. Yep, there's an underscore in there. So that's how, stuff that has been used before in your program, in your code. You have your employee class, you have the different department class, you have the product class, you have the sales class, and all whatnot. And when each area that you need to use that information, you go ahead and import that and reuse it as possible. So again, libraries, you're just borrowing, just like a library in real life. You go and borrow a book and use it, assimilate or accumulate all that information and knowledge. You go and return the book, and so on and so forth. So that's what we'll use libraries for. So in that case, you can import the entire library or import specific library modules or functions within the library. So some popular libraries that you see out there, there's quite a good number of them. I mean, I'll be lying to you if I tell you that I know the number of libraries. Anyone will be lying to you if they tell you that they know the number of libraries out there. So just to point out a few popular ones, there's NumPy, which again is numbers in Python. It's general purpose. We talked about arrays like list. So it's used for array processing, but it's a lot faster. It's quicker to use it. And it's a fundamental package for all scientific computations in Python. Okay. There's also SciPy for scientific computations. Everything that has to do with NumPy is being used in there as a basic structure. So it looks at things together in an array-like format. Okay. So it use it for many mathematical functions, whether it's quadratic equations or calculus, algebra, solving all other equations and so on. So that's something useful. Imagine the time it took us to solve quadratic equations. Nowadays, if you need to figure all those things out, you just plug it into Python. Python gives you the answer right away. Right? So pandas is very popular as in data science. Everything that has to do with data will probably have to pass through pandas. And pandas are used to deal with data analysis and manipulation. So it helps you to organize and manipulate data. It's very good, very useful. It puts it in a tabular form instead of using databases, which are very huge, and it's also challenging to build those relationships. Most of the time, you have input or output in the form of a CSV file or a JSON file. We talked about CSV. We also talked about JSON earlier, and those data, there's data all over the place. You can usually just use pandas to quickly, look at the data, give you an idea of what the data is made up of, and so on and so forth. We'll be looking at pandas a little bit more today, just a little bit more, but I won't be able to have enough time to go through each one of these libraries. I encourage you to go ahead and look at them in your free time. And as long as you've understood the basics of what an object is, oriented programming, all of these libraries are pretty much just creating objects. Okay, so it creates an object. Once that object has been created, you can access the attributes of the object, or you can use the methods to get particular things to be done for that object. Okay, so matplotlib again It's also a very popular library because they use it for visualization. You can get interactive visualizations that you can zoom, pan, update. You can also get static or animated images created for you. And scikit-learn is used for machine learning. Everybody knows what artificial intelligence is nowadays. Artificial intelligence is very popular, and we'll probably take a look at an example. Hopefully, in the second part of today, I should be able to look at an example where we can use some cognitive learning to write a quick program that can do a translation for us just using Python. Will probably take us 10 minutes to write a piece of code and publish it on the web that you can go in and do translation from one language to another very, very easily by leveraging Python and a framework. But we'll get to that later on. But all of those are built on things like machine learning as well as artificial intelligence. Another thing that we'll get to talk about is TensorFlow, or not talk about in depth today, but artificial intelligence is a subset of machine learning. So you can use scikit-learn library to leverage that. You can use TensorFlow, which is an open source AI library for flow charts or flow graphs, and it does everything from classification, perception, understanding, and so on. So whatever it is that you want to use Python for, whether it's for automation, whether it's for administration, machine learning, artificial intelligence, data analysis, as you have seen in here, these are just a few of the libraries, but there are so many out there. In fact, if you go in to Google and type Python libraries, you would have countless number of libraries out there. Normally, if you look at, say, images, it will give you a better idea of the different libraries. This just tells you about 10 of them, but there's a slew of libraries out there that you can use. That's here you can see sci-fi, matplotlib, pandas, and so on and so forth. There's just way too many that we will not be able to ever go through all of them. So there's a bunch of different libraries. It's up to you which one you want to jump into, and it gives you synopsis of each one of those. And these are the popular ones that we've talked about. Does anyone have any questions so far? So we've just mentioned about them. We haven't talked, I don't know if anybody is speaking, but we are all on mute. So let me take a quick look at the data that's out there. Let's try to use one of these libraries, right? Let's take a look at pandas, because pandas are very popular. So I went ahead and wrote a piece of code in here. If I can find it, I don't want this, I don't want that, I just opened that actually. So this is an example of a file that I actually just downloaded. You can always get a bunch of data online, right? If you go, for instance, and look at data, maybe I should just search for open data. And you see there's a bunch of data out there. So this is going to point me to Detroit because it probably looked up my location. But if you go to data.gov, you see about 250,000 data sets are available for you, whatever you want to do. So you can look at the ones that are recently added, the ones that has to do with geographical locations, organizations, or most viewed sets, and so on and so forth. So I clicked on one earlier, and I tried downloading this. This was a little bit large for crime data from 2020 to present for LA. So again, it shows you the different formats: CSV, whether it's comma separated values, RDF, JSON, which we've talked about, JavaScript object notation, and it gives you some kind of annotation. This one is for a city, this from federal, that's from state, and so on and so forth. So there's bunch of data out there. The one I downloaded is the lottery Powerball winning numbers from 2010. Okay, so I downloaded that. You can see in here I created another folder that's called data. In this folder I have that in there, and I also have US COVID data set. So if you double click on this, it shows you what the data set looks like. But I'm going to use Pandas to be able to pull that. Okay, so to use Pandas, obviously, I'm importing Panda as PD. I'm using that to be, since it's shorter, right? It saves me a few letters here and there. And I'm going to create what is known as a data frame. A data frame is an object, right? Just like your employee created an employee object. Pandas is going to create a data frame object for you when you call it. So all I needed to do was within the location of my file is week 5 right here, which is currently live. I have a copy of that particular file, which is in CSV, comma separated values. So once I type in PD and I use that dot notation, I can use a bunch of the different functions or methods within that particular library. So I'm able to read a CSV file. You can also read JSON, you can read text files, you can read different files. So if we want to see, for instance, the different methods that are in there that we can use, let's go ahead and try. Actually, let me use that same. Yeah, I should use the same one then and show you what I mean. So let's open, oh, I don't want that. Let's open the file up here. I'm going to import Pandas as PD. And then what I need to do is dir is going to show me all the different functions that are within Pandas that I can use. If I execute this, it shows you all the different functions that you can use. Okay, there's quite a lot of them. We don't have time to look at each one of them. Now, if I create a data frame in here, when I use df, I created a data frame. I can go ahead and also look at all the different functions within the data frame that can be used. If I use dir, df, it's going to print out all the different functions that I can use in the data frame. So within the data frame, you have a bunch of all of these with initial underscore are private ones that you can only access using methods within it. So you can add to your data frame, you can find the axis, you can combine, you can find a column, and so on and so forth. So there's a bunch of other things in here that we can use. I don't want you to be overwhelmed with this. I want you to just understand that there's so much power in just that one import statement. We can do so many things within our Python. So let me delete that. I've been able to import, let me delete this as well and run this again so it's clear. Okay. So now I've imported Pandas, I've read that input. Now I have a data frame. I need to check the columns of the data frame. If I execute this, it tells me that that data frame has a draw date. That's the date that the winning numbers were drawn, the winning numbers, and a multiplier. I think they usually have, I don't play much of that Powerball or lottery thing. So again, it tells me the different categories that I have in there. If I want to see just the top records of that data frame, I can go ahead and execute that. It tells me these are the records. The first record is from 2020, September 26, and these were the winning numbers. So if somebody asks you, hey, can you get me the winning numbers for Powerball for a particular year? It's simple. There's open data. You go ahead and grab this data from here, and then you write your little Python script to open the Pandas, and then you get those data sets out there. There are many ways that you can also use that. You can also do a data frame, data types. It tells you each of those data types. The data type is an object. The draw date is an object. So this is currently an object. The winning numbers is an object. Yeah, this is also an object because it's creating an object of winning numbers. But then when you get to the multiplier, it's a float. So it just gives you a floating point number. Okay. Also, if you want to get just the general information about your data, that data right now, everything in here in that CSV file is currently saved in this variable df, which is a data frame. So I can go ahead and say df, give me the info. That's the info method that I'm calling for that same object. If I run that, it gives me that, hey, there are total of 3 columns and the range is 1,464 records, which begins from 0 to 1462. And it tells me how much memory is being used on my system. So it tells me the data types, blah, 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 blah. If I'm interested in just the first 5 records, I can type in head in as a method, and it gives me very nicely, this is what my table will look like. If I want to see the last 5, I go ahead and use tail, and that's going to give me from 1458 all the way to 1462. Okay, so this is the Powerball number for yesterday. In case we're too lazy to go search the internet or go look at the recording of yesterday's drawings. So from here, if you want to start seeing statistically the numbers that have never shown up, you can probably use some data analysis to get those numbers. Now, if you want to look at just a particular column, let's say the winning numbers, remember that data frame is like a dictionary. Okay, this dictionary has keys and values. So the keys in this case would be the columns. So the winning number is a key. I want this data frame to give me just the winning numbers. If I execute that, it gives me just the winning numbers. This is the winning number for the first record, which is 0 index, and these are the winning numbers for the last record, 1462. And it tells you the information. The name of the column is winning numbers. There's 1463 records in there, and the type of data is an object. If I wanted just the top 5, I'll go ahead and use head. If I wanted the last 5, I'll use tail. I can also decide that, hey, I want 10 instead of top 5, give me top 10. If I execute that, it gives me top 10. If I wanted 100, I can go ahead and update that as well. So if I use tail, 100, gives me the last 100 from 1363 to 1462. Okay, so there are many ways in which you can use head and tail to have an idea of what your data looks like. But if you want to look at multiple columns within your data set, then you have to use, initially we just entered directly the column name. But if we want to enter multiple columns, that means we are entering a list inside here. So that's why we end up with 2. If we're going to enter a list now, we know that our list is going to be something like that. So that's what we're going to enter in here. That's why it's written with 2 square brackets. Now, if I execute that, let me hide this. If I execute this, I can now see, okay, winning numbers and multiplier. But if I want to also add the draw date, I think that was, I can still add the draw date. I don't necessarily need to add another square brackets because those 3 items are within a single list. So if I execute that, now I see the draw date, winning numbers, and multiplier. So sometimes you might have 100 columns, but you're only interested in a few columns. So that's how you'll be able to pick out those columns that you need. For those who have done SQL, you probably understand this looks more or less like a select statement, right? In SQL, you necessarily go to select everything from a table. But in Pandas, what you do is you create your data frame, which will be a table, right, as we've seen here. And then within your table, instead of selecting everything, you have your names now of your column 1, column 2, and so on and so forth. Okay. Does that make sense to everybody? So in a nutshell, that's how you go about, playing around with Pandas to get your information that you need. And it's very easy to navigate through and also see all those different things that are necessary. Sounds good. What questions do you have? So we can also use an API. I know we mentioned, I've talked about CSV, I've talked about JSON and an API. API again is an application programming interface. That's how one application sends information to another application. So for instance, if we need to look at, say, weather, right? There's a website that actually has weather information. I think I showed you guys this on the very first day. So let me open, where is my weather function? Actually, I don't want the weather function. I want the weather file. So here is an example of a function that, or should I say, piece of code that imports the request library. This request library is used to get onto the internet, right? So in order for me to get information from Open Weather Map, let me go ahead and see. Open Weather Map is actually, as it says on here, it's a weather forecast website that you can use to forecast weather in any particular city and so on and so forth. So they have made their API available. If you click on the API, it gives you information on how you can get, or tells you how you can set up your information and call the data as you need. So I think in here, where's my documentation? Yep, here's the API documentation. So how to call it, all you need to do, all that information that's needed, and the JSON, how it's set up, and so on and so forth. So in here, it gives you an example how you can use that application, because this is a web application, the openweathermap.org, that you can use to implement in your own to pass information to you. So let me switch back to Visual Studio Code. I think I had one in here, except I lost it. That's fine. Let's go back to here then. So in here, what I'm doing is I created a key in order for you to be able to use their API, because they don't want everybody to just use it anyhow and crash their servers. You need to go ahead and create a key. That key makes it so that each time you're able to get just information that's available for your quota. Sometimes they can decide, hey, if you're going to create an app and put it on the market, many people are going to be using the app. They're going to be requesting. Maybe you can set it up to be running real time. So you probably have to pay for premium service. For that premium service, they'll give you a new key, and you can request as many, you can have as many requests per second. But for this session, we just went ahead and did a free version. So we can write a for loop, for instance, to ask infinite number of times to just keep updating. So we have a variable that's holding our API key. We also have a variable that's, normally I would have this hard coded to a particular city, but I'm setting it so that the user can input the name of their city. And also the URL, which is the base URL. As you can see, it points to that particular weather app. And then I'm appending the city that's going to be inputted, and also appending the key that I have to use. In this case, I'm making sure that I set my units to be imperial. Otherwise, it's going to give me, the universal units. That is not what we usually use in the US though. So with all of that, I create a URL, and that URL is what I'm using to request that information. That's why I needed this request library to be used so that I can get information from that URL. When you get to this URL, let me go ahead and print. Let's see, let me just print that particular value so that we can see it. Print URL. Okay, so if I execute this, it's probably going to ask me to enter blah, 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 blah. But let me execute that. Where is it? Oops, I can't execute it that way. Why can I not execute it that way? Because this is a Python file, right? All along, I've been pressing the play button because I've been using an interactive Python notebook. So in order for me to execute this file, I need to create a terminal. So let's click on Start plus create a terminal, and that's just like a regular terminal you see on your machine. So within this terminal, for me to be able to execute this, I need to type Python and the name of the file. So that's lab 10 weather.py. Okay. So with that, I'm telling it, hey, open the Python environment and run this query or run that Python script. So if I press enter, it's asking me for the weather, or sorry, the city in here. So let's give it a city, say New York. And it has outputted that URL that I did save. I really wanted to get that one so I can show you guys what it looks like. So it's outputted that, and it's telling me today's forecast for New York is mist. The minimum temperature is 52 degrees. The maximum temperature is 58. Now, if I go to that URL that I just copied and press enter, this is what it gives me. So this is a JSON file. Okay, the JSON file has three, probably more than three. It's like a dictionary. Think about the dictionaries we learned. So if I want to get a better view in here, okay, here's an example of the file that I downloaded. So if I open this, it actually outputs it very nicely for you. So you can expand. Let me look at it side by side. In here, you see it started with coordinates, temperature, type. And if you look at what we have here, you have coordinates, you have temperature somewhere, I'm not sure, and type somewhere else. But yeah, the good information, you can see that you have coordinates. It's a folder in there. There's a weather. And for this particular one, you have a description and so on. I think somewhere should be a city. In the main, you can see the main temperature that's in there. And I cannot see the city though. Missing it somewhere. Winds, clouds, system. Okay, so I think this is where the city is shown. So in the system, you can see the name is Orlando. That was for Orlando. I can't remember what date I won that. And this country is in the US. It tells you the sunrise and the sunset. So all that information, you can actually get it because that information is available for you in JSON format and can be transported over the API. Okay. So with that, all you needed to do was to import the request to be able to get information transported over the internet into your Python file and use it as you need. So again, I can go ahead and still run that. And let's say I want to check the weather in Douala. And it tells me the forecast in Douala is light rain. And so on and so forth. So you can ask for the forecast anywhere. Let's try, I don't know, Atlanta. Atlanta has a few clouds and the temperature is in there. So all of that is because we understand how we can leverage that information. We're using that weather.json to get the JSON value from our request. That request is what we have in here. So it's pulling it in the format of JSON. Now that we've pulled it in that JSON format, we are able to use the get method to get the weather. Within the weather, we go into the first item and get a description. So if we come in here, we went into, let me collapse all of these. We went into weather. Instead of coordinates, we didn't go into coordinates, we went into weather. Within weather, there is one item in there. In that item, we pulled out the description. Okay, so that's how come we're able to get the description. If we wanted the temperature, which was the minimum temperature, we had to go into the main, or should I say, in the dictionary, go into the value that corresponds to the main key, and then get the attribute for temperature minimum. So let's check that out right here. So not weather, we want to get into main. and then check for temperature minimum. And the same way we can get the temperature maximum and so on and so forth. So that's how we're able to pull that information for the minimum and maximum temperature, and then we outputted it here and added degrees. Does that make sense to everyone? Question, Aaron.
So the API key, how did you get that? Is that part of what you read from the document?
Very good question. The API key, most of these, they just need you to go ahead and sign up. Sign up for free, and then it gives you an API key. So in order for you to get that information, all you have to do is sign up. So where is it? It's taking its time to load. Allow cookies. Yep, so I'm scrolling down real fast. Sorry about that. That way you don't get dizzy. Let me search for documentation. Sorry, I had to get into API. Never mind. API. So in order for you to get, this is a newer version actually. I'm not sure when this one came up. In order for you to get it, you go through the API key. Sorry, I just saw it. So all you have to do, please sign up to use our fast and easy to work, blah, 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 APIs. As a start, blah, 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 we recommend to make calls to this. I was making calls to 2.5, but that's fine. It's still the same. So all you have to do is sign up. When you sign up, it gives you an API key. And that API key, you can use it whenever you need to. Okay? Again, sign up. You don't need any credit card or that information. Just username, email, password. It confirms that you're 16 years or older, you agree to their terms, show that you're not a robot, and that's fine. Maybe you don't need all this stuff if you don't want them to be sending you news. You create your account. Once you create your account, you should come with an API and you should be good to go. And once you get that, frequently asked questions will usually help you. What is the one call, by call, subscription, and so on and so forth. So yeah, where can I find how much calls I make and so on and so forth. Again, can I use your product for free? You can make 1,000 API calls per day for free. So after 1,000, they're going to tell you, sorry, wait until 24 hours before you can make another call. Otherwise, you get order. You can subscribe for 1 month and so on and so forth. Sounds good?
Yeah, one more question,
yes.
if I may. If you go back to the code, to the program you wrote, yeah. And the way that you have the assignment to the variable URL. So how did you know you have to put city where it is and the API key where it is?
Very good question. So that is actually within your documentation. In the documentation, they'll tell you how to call the API, right? So here it says how to make an API call. It tells you right there to make an API call, use this syntax. You can use latitude or longitude if you know the latitude or longitude, or you can use a particular city if you want to call it by city. So latitude and longitude, you can see it in here, and so on and so forth. So some applications have very detailed documentation. It's the same as Twitter, right? If you want to see Twitter search results and so on, you can go to the Twitter API. Twitter API has its documentation. Okay, again, depending on what version, is it the basic version or the new version? In there, it tells you, okay, access levels. Free access levels, you can write only or provide only use cases, blah, 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 blah. It allows you to have 15,000 tweets per month. So you can use it to also set up your tweets and so on. So you have here getting started, all the information you need to get access, make your first request, and so on and so forth. It tells you what you need to do and how to make the request. So here is a URL for Twitter. You have to put your username and your authorization. So the bearer token is what you'll be given once you sign up to use it. So in this case, it's the same with Google, Facebook, all those different applications. You just sign up as a developer, you get an API, an access key. That way they want to monitor how many times you use their stuff. and it helps them too. That way they don't get bombarded and then shut down their service. Does that help?
Yeah, thank you.
You're very welcome. Yeah. So again, information is out there. You can use Python for a lot of things. You can even use Python if you want to set up birthday emails. You want to email friends, reminding them of their birthday, happy birthday, and so on and so forth. So there are many, many things that you can use Python for. How can I say? For automation, right? So for Python, for the birthday stuff, let me see. There is an example here actually. Unfortunately, I don't have all the information in there, but let's see if I can paste that piece of code in here and then we can look at it. Day 10, where's my day 10? Oops, sorry, it's not in here. It should be in here instead. Day 10, let's create a new file, auto email.py. So let's go in here. This would be an example of how you would create an automatic email. So a few things that you're going to need. You need to import Pandas, right? You need to import datetime. You need to import SMTP. Those are all different modules, so with different libraries that you import. So let's see, and then here, toast notifier. So again, you want to set up your email, your password, and then again, this for a desktop. I think this is not for, and that's gonna be resolved. That's not good. So yeah, I should be able to import Pandas. But a few things, you connect to your email using that SMTP, as you can see. You can send an email directly. SMTP is Simple Mail Transfer Protocol, SMTP library. And send an email, you create an object that's going to be your Gmail object. You give it a subject and so on and so forth. The key thing here is you're sending SMS using another particular link and so on and so forth. But automating it, you can go ahead and notify. I think Pandas here, I needed Pandas to be able to, let me see, control find. Yep, I needed Pandas to be able to read an Excel file. So in this Excel file, you're going to have the names of your friends who have birthdays and their birthdays and so on. So from there, you should be able to see in the data frame, you search the index and the item. Many returns is going to be inserted into the person's name. And then the birthday, you're pulling it from the birthday in the calendar, right? Or not in the calendar, in your Excel spreadsheet. From there, you're checking if today is the same as their birthday, because the birthday, you're pulling it from the item in your data frame. There's a column there that's called birthday. If those two are the same, then go ahead and send them an email, and that's it. Otherwise, if it's not the same, you go on to the next one. At the end, when you go at the end, you go ahead and close your Excel file. So again, data frame, you're getting it to Excel or getting it from Excel. So that's how you can make things really automated. You've already understood the bulk of what Python is doing. You know what it means to import. You need to just research a little bit and say, what library can I use so you don't have to reinvent everything? So you get Pandas to pull in your Excel file and make it to look like a table. You can get every column, compare it to, again, date time is a function that you use, or should I say, library that you use to be able to get today's date. That datetime.now, you're able to get today's date. And then you check the year. And then from that year, you know how old the person is. And then you can use that today's date to compare it with the date that you have in your birthday column of your data frame. So you just have to break down the problem into smaller chunks that you can use, and then you'll be able to get that. So you have seen quickly, even though we did not demonstrate this because I have to set up a spreadsheet with all the names of my friends, their birthdays, and their emails. and then automatically send them an email. So if your boss is sending everybody happy birthday every month, they probably have a script like this that was written and delivered to them. So they can have a list of all the employees, their birthdays, and their emails. So that on the first day of that month, it sends out that email and everybody is happy and good and you feel special. They can probably have different types of messages, and then they can randomly change those messages and say, hey, have a wonderful birthday, happy new year, and so on and so forth. If the birthday is, if the difference is 10, or you get a year and say happy 10th anniversary, happy this, and so on and so forth. So those are all ways you can leverage Python to do wonderful things for you. Sounds good?
Yep.
Excellent. So we've talked about all those different libraries. We looked a little bit at Pandas. I would have loved to look at Matplotlib, but we ran out of time because I wanted to be able to show you some plots. But it's easy as Pandas. So if you need to learn more about it, Matplotlib, Python, you can go onto their website and they'll tell you all the wonderful. These are some of the visualizations. As you can see, it's very easy for you to look at it. There are a bunch of examples. I think you should be very comfortable going through to check out the examples and looking at them, say basic sections, look at the bar chart. As for instance, right here, you're importing Matplotlib. In this case, you want this particular module, pyplot, and you're going to call it pyplot or plot. You're using NumPy. Okay, NumPy, simple arrays. In here, you're going to grab that. Maybe you're going to get a random number from 1 to 3, and then x would be 0.5 plus that, just to create some kind of random numbers. Once you've created those random numbers, you can now create a figure, have an axis that's going to be subplots, and then ax bar, you get that information, x and y, plot it, and this is what it looks like. So if you already had data that has been given to you in CSV format or maybe in an array format, you can easily go ahead, plot your data and show it in Python very easily like that. If you want to look at a scatter plot, there's examples of a scatter plot, how you can plot that data, or just a regular plot. You should be able to plot it easily. The main thing here is understanding how to import, understanding the dot notation, understanding how to call a particular column within your data, and all the different functions. If you need to know what functions are out there, you can use dir or you can use help to give you more details about each library, and you can plot as many as you want. Not necessarily for basic stuff, you can also look at unstructured coordinates. Something like this, you can get geospatial and so on and so forth. You can also look at 3D, plot them using Python. So it's very, very powerful to be able to use any of those. Sounds good? It's the top of the hour. I think it's time for us to take our break. When we come back, we're going to look at frameworks. I'll probably try seeing if I can develop a quick application for us that can do a simple translation, and then we should be good to go. So it's going to be a fun round up, probably 10 to 15 minutes for us to get that application up and running. Sounds good? All right, so let me go ahead and give us a few minutes, 10 minutes, and then we'll come back and carry on from there. For 10 minutes. Excellent. All right, see you guys in 10. Let's find some music too.